In this video, we're going to look at evaluating calculations involving fractions. Now, the word evaluate is going to crop up in each of the questions I look at here. The word evaluate basically means do some number work to get an answer. We also need to realise that fractions are just numbers. And because fractions are just numbers, they need to follow the rules that all the other numbers follow. In this first question here, I have got evaluate 5/8 minus 2/9 times 3/4, giving your answer in its simplest form. I need to evaluate this, but I need to note there is a subtraction and a multiplication in this calculation. You should know already that multiplication and division take priority over addition and subtraction in calculations. So basically, I am going to have to zoom in on this bit here and carry it out first before I worry about dealing with that subtraction. So I have got 5/8 minus 2/9 times 3/4, and I'm going to focus on the multiplication first. So multiplying fractions is literally the easiest thing in the world you can do with them. We could just multiply the top two terms together and the bottom two terms together. However, it's useful at National 5 to look at simplifying your fractions before multiplying. So this is true when we're working with number fractions and when you're working with algebraic fractions too. Now, the way we do this is we examine the tops and the bottoms, the numerators and denominators, and look for a pair of numbers that have a common factor. 2 and 4 are both divisible by a factor of 2. So if I divide the top by 2, I'm going to get a 1. And if I divide the bottom by 2, I'm going to get a 2. Examining the pair that's left, 3 and 9, I can divide both of those by 3. So 3 goes into 3 once, 3 goes into 9 3 times. So now that I've simplified that a little bit, I can go ahead and perform that multiplication. So I know this is going to equal 5/8 minus, times in the simplified numbers together, 1 times 1 over 3 times 2. Now, adding and subtracting is a little bit more difficult because you need to make sure your fractions have a like denominator. Here, I can't just subtract 8 from 6. I need to convert both my fractions so they are the same type of fraction, so their denominator is the same. I need to change them into a number that has a factor of 8, i.e. it's in the 8 times table, and as a factor of 6, it's in the 6 times table. You could aim for 8 times 6, which is 48. However, you should be trying to be a bit more smart with this. 24 is in the 8 times table, and 24 is in the 6 times table. Aim for the lowest common denominator, the smallest number that's in the 8 and 6 times table, and that will save you having to do any unnecessary simplifying. So the 8, I needed to times it by 3, so I times the top by 3 as well to keep it an equivalent fraction. 15 out of 24 is the unsimplified version of 5/8. The 6, it got timesed by 4, so I need to times the top by 4. 1 out of 6 is equivalent to 4 out of 24. Now I can just go ahead and perform the subtraction. My answer is going to be out of 24 because that is my common denominator. 15 take away 4 is 11. Now I'm going to quickly check if this will simplify. 11, the only numbers that will divide 11 are 1 and 11. Well, dividing by 1 isn't going to help me simplify, and 24 doesn't divide by 11. So my answer will not simplify any further. We're done with the question there. Now, part of the reason that this is in its simplest form already is because of the two sort of smart things we've done. One, simplifying our fraction there, and two, using the lowest common denominator rather than just going, what is 8 times 6? It's worth noting that whenever your answer is a fraction at any level of maths, National 4, all the way up to Advanced Higher, it should be in its simplest form to be considered correct. So it spells it out here, but you should be in the habit anyway of simplifying your fractions. At National 5, a majority of your evaluating fractions questions are going to involve things like this. They're going to involve mixed numbers. So here, I've got a simple subtraction, so I don't need to worry about what order to do things in. But this is made a little bit trickier by the fact that 2/5 is smaller than 5/6. So the 3 take away 1. That's easy enough. 2/5 is less than half. Well, 2 is less than half of 5. 5/6 is more than half because, well, 5 is more than half of 6. So basically this fraction isn't really big enough to take away 5/6. There are a couple of ways you can deal with this, but the way I would recommend is by taking your two mixed numbers and converting them into improper fractions, converting them into what's sometimes called a top-heavy fraction. There's two reasons for that. One, it's going to get rid of the fact that these fractions are awkward to take away from one another. The other reason that's a useful thing is when you do any multiplication and division, you have to convert these into top-heavy fractions. So it's a good habit to get into, just converting them into top-heavy fractions automatically. So that's what I'm going to do here. To do that, I'm going to look at the denominators. First fraction is fifths, so I need to convert that 3 into fifths. I need 5/5 to make one whole. So to make 3 wholes, that will be 15/5. Take a second to look at this. 15 divided by 5 is equal to 3. So my 3 is the same as 15/5. I've got 2 more fifths to add on. That means 3 and 2/5 is the same as 17/5. The next one, the denominator is sixths, so I'm dealing with sixths here. 1 whole is 6/6. So I have got 6/6 and 5/6. I have got 11/6 altogether. I've got a subtraction, I've got unlike denominators, so I need to convert them both into equivalent fractions with the same denominator. 5, 6, the smallest number that's in both of those times tables is 30. So this means I'm going to have to times the top and bottom by 6 for the first fraction, and the top and bottom by 5 for the second fraction. Now, at National 5, the worst bit of number work you will really need to do is take a number and multiply it by a single digit. There is nothing wrong with setting out little column multiplications like that, chimney sums if you want to call them that. Don't be scared to do that. So 17 times 6 is 102. 11 times 5 for the second one, that is just 55. My answer is going to be out of 30 because both my fractions have a denominator of 30. 102 take away 55. Well, 55 plus 45 is 100, so 2 more will give me 47. Now, the question specifies in its simplest form. So I'm going to check whether or not the top and bottom will divide by the same thing. 47 is actually prime, so, well, anything that divides 30 other than 1 won't divide 47. So these won't simplify down. That is a perfectly acceptable answer. You do not need to convert that into a mixed number again, unless the question tells you to. If you wanted to do that, you go 30 goes into 47 one whole time with a remainder of 17. However, for the purpose of this question and fractions questions in general, it's perfectly reasonable to leave it as a top-heavy fraction. In some cases, it's preferable. If you were working with a gradient, a top-heavy fraction is much easier to work with than a mixed number in that circumstance. Now, here we've got another evaluation question, another bunch of mixed numbers. I've got some brackets involved. I've also got the word of. What you need to realise in a calculation, finding a fraction of an amount is the same as multiplication. Justify that just over at the side here. If you think of this, a half times 6, we can think of that as 6 lots of 1/2. That is 3. If I rewrite that as a half of 6, well, a half of 6 is also 3. So the word of essentially means multiplication. So I can rewrite this to begin with, getting rid of that word of. 1/12 multiplied by 3 3/8 divided by 3 3/4. I'm going to close my brackets there. I'm not going to touch the 1/12 or the multiplication. I'm going to deal with what's inside the brackets first. Because this is a division inside the brackets, I'm going to be forced to convert both of these into top-heavy fractions. You cannot divide mixed numbers by one another. This is why I said earlier in the video it's a good habit to get into, just converting them into top-heavy fractions anyway. So I'm dealing with eighths in the first one. My denominator is 8. 8/8 make 1 whole. So 24/8 will make 3 wholes. Just a quick check. 24 divided by 8 does indeed give me 3. So it means I've got 24/8, 3 more eighths. I've got 27/8 divided by. Right, the second fraction is quarters. 4 quarters make a whole, so 12 quarters make 3 wholes. Again, another quick check. 12 divided by 4 does give me 3. So I've got 12 quarters plus 3 quarters. That is going to give me 15 quarters. Still need to work out what's inside my brackets, so not doing anything with that 1/12. I need to remember how to do division with fractions. To divide one fraction by another, the thing you're dividing doesn't change. And instead of dividing by a fraction, we can multiply by its reciprocal. So this idea of my division is multiplication, and this fraction gets flipped. Again, you should be comfortable with something like this. You know dividing by 2 wholes, i.e. dividing by 2, is the same as multiplying by 1/2. So multiplying by the reciprocal saves us having to divide by a fraction. So I've got 1/12 times. Now let's zoom in on this bracket. I could, if I want, go and do 27 times 4 and 8 times 15, but this has been set up deliberately for us to simplify first. The 8 and the 4, that is crying out to be divided by 4. So 4 goes into 4 once, 4 goes into 8 twice. The 27 and 15 both of those have got a factor of 3. So 3 goes into 27 9 times, and 3 goes into 15 5 times. At National 5, we should be more than capable of doing things like 27 times 4 and 15 times 8, but we don't need to in this case. By simplifying the fraction, we make it a lot easier to work with. So we can go ahead and multiply the simplified bits. 9 times 1 on the top, 2 times 5 on the bottom. No need for any simplifying there. Zooming in again, we've got multiplication left, and again, we could multiply straight away. 1 times 9, 12 times 10. But I'm going to simplify yet again. The 9 and the 12 both have a common factor of 3. So I can divide both of these by 3 to get a 3 and a 4. And this allows me to get a simplified answer at the end. 1 times 3, 4 times 10. Now again, just a quick check. Top's 3. Will 40 divide by 3? No. 39 is the closest number in the 3 times table. So this will not simplify. But again, because I have simplified as I've went, it's kept these numbers nice and small, removing the need to really do any serious simplification. So, to conclude, you need to remember when you're working with fractions, your order of operations still apply. So, you need to remember things like multiplication and division before you move on to any addition and subtraction. You need to remember that it's useful to convert to top-heavy. So that is vital for multiplication and division, and it's useful for addition and subtraction. And last but not least, you need to remember to simplify as you go and at the end, because you will kick yourself if you lose a mark at the end of a question because you have not done your simplifying.